Hello students, for the past two classes we started learning about circles. So I give a quick recap what we learned and then we will continue with the exercise. Remaining problems in exercise 10.2. So we have learned what is meant by a tangent to a circle. What is a tangent? A tangent is a line that intersects the circle at only one point, or else we will say it touches at one point. Right, and we have seen the tangent at any point of a circle is perpendicular to the radius through the point of contact. This is one important theorem what we have learnt. The tangent at any point of a circle is perpendicular to the radius through the point of contact. Through the point of contact, the radius which is drawn is perpendicular to the tangent, right? And then we have seen another theorem based on the length of the tangents drawn from an external point to a circle. And also we have seen there can be exactly two tangents that can be drawn from an external point. And what about the length of the tangents drawn from an external point? Both will be equal in length, right? And this we proved using congruency. And through this theorem we obtained an observation that this angle is bisected by this OP. Right? What is that? Center lies on the, and also we inferred that center lies on the bisector of the angle made by the two tangents. Right? What we inferred? Center lies on the bisector of the angle made by the two tangents. These are the important results what we learnt in our previous classes. Now let us continue with exercise 10.2, question number 4. We completed till question number 3 in yesterday's class. And now we will move on to question number 4. Question number 4, what they asked you to prove is, prove that tangents drawn at the ends of the diameter of a circle are parallel. We need to prove this is a circle and this is a diameter. We need to prove the tangents drawn at the ends of the diameter are parallel. And we know very well in class 9 we have learnt about lines and angles. To prove two lines are parallel, we need to prove alternate angles are equal, or corresponding angles are equal, or co-interior angles are supplementary. If we prove any one of these three things, then the two lines will become parallel. Hope you remember, because the converse is also true. The conditions for two lines to be parallel. If the lines are parallel, then the alternate angles will be equal, corresponding angles will be equal, and co-interior angles will be supplementary. And the converse is also true. If these three things are possible, then the two lines will become parallel. Yes, so that idea only we are going to carry here. We need to prove CD is parallel to AB. So what are we going to prove now? We are going to prove alternate angles are equal or corresponding. We have to search for it and then we will conclude that, and hence the two lines are parallel. Alright. So before we getting into that, we know this QP is the diameter. So what about OQ and OP? OQ and OP are the radius. OQ and OP are the radius. Just now we recalled a theorem which says that the radius drawn at the point of contact of the tangent is perpendicular to it. Therefore, this angle is 90 degree, this angle is also 90 degree, and hence this is also 90 degree, this is also 90 degree. Yes or no? Yes. And hence you can infer that this angle is equal to this angle is equal to this angle. What two these angles are called as? Alternate angles. Angle OPA is equal to angle OQD. Similarly, angle OQC is equal to angle OPB. Right? So, if you take these two are the lines, and if PQ as our transversal, we see that the alternate angles are equal, and hence the two lines are parallel. Right? Hope you understood. Let me show you how we can present this. Now see, let AB and CD are the two tangents drawn at the point of contacts P and Q respectively. Then by the theorem we know that radius is perpendicular to the tangent drawn at the point of contact. Therefore OP will be perpendicular to AB and OQ will be perpendicular to CD. What does it mean? This angle is 90 degree, this, all the four angles are 90 degree, which implies OPB is equals to angle OQC. Similarly, these two angles are equal, but they are alternate interior angles, and hence CD will be parallel to AB. That's it. Right? Hope you understood. Let us move on to the next question now. We are in fifth question now. What is given is, they are given a circle with center O and AB tangent at B. They ask you to prove that the perpendicular at the point of contact to the tangent passes through the center. I repeat, what they asked you to prove is any perpendicular which is drawn at the point of contact of the tangent, any perpendicular which is drawn at the point of contact which passes through the center, that's what we need to prove. So what are we going to do here is, we are going to consider a contrary. What happens if it does not pass through the center? Okay, so we know O is the center of the circle and AB is the tangent. We need to prove a line perpendicular to AB passes through O. Now let us assume, suppose a line perpendicular to AB at P does not pass through O, but passes through some other point, say passes through some other point, say O dash. Now what will happen? See, what we have done here is, suppose it passes through some other point O dash, it does not pass through O. Then join O dash P, then what is O dash PB angle? Which is 90 degree, because we have constructed a perpendicular. We are talking about a perpendicular only. We have constructed a perpendicular from at the point of contact P. It is not passing through O, it passing through some other point O dash. But even then, since it's a perpendicular, it should be 90 degree. But what you know about OP? O is the center of a circle. Therefore, OP is the radius. Therefore, angle OPB is also 90 degree, because we learnt a theorem which says that the radius at the point of contact is perpendicular to the tangent. Therefore, OPB is also 90 degree. From 1 and 2, what do you infer? This is possible only if O and O dash coincide each other. This is also 90, this is also 90. This is not possible, right? How it is possible if O and O dash are two different points? Only if O and O dash coincide, we will get both angles as 90 degree. And hence, the perpendicular drawn at P passes through the center O. Right? So, every perpendicular drawn at the point of contact will pass through the center, and on the other hand, the same way the radius will be perpendicular to the tangent at the point of contact. You should remember both the results. Hope you understood. Let us move on to the next question now. Now let us see how can we solve our sixth question. The length of a tangent from a point A at distance 5 cm from the center of the circle is 4 cm. You have to understand the question and you should draw the diagram correctly, then only you can solve it properly. The length of the tangent from a point A at distance 5 cm from the center. So the distance between center and A is 5 cm is 4 cm, which means the length of the tangent is 4 cm. They asked you to find the radius. This can be easily solved using Pythagoras theorem, because we know the radius is perpendicular to the tangent at the point of contact. Therefore, this is a right angle triangle. You can apply Pythagoras theorem and you can find OB. OA square minus BA square will give you OB square. So, I am leaving this problem as homework to you. Let us move on to the seventh question. Two concentric circles. Concentric circles means what? Two circles with the same center but different radii. Alright. Two concentric circles are of radii 5 cm and 3 cm. Obviously, the bigger circle will have radius 5 cm and smaller circle will have radius 3 cm. Find the length of the chord of the larger circle which touches the smaller circle. They asked you to find the length of the chord of the larger circle which touches the smaller circle. So, they asked you to find the length PQ. So how can we find? Again in the same way, by applying Pythagoras theorem. Join OR, and we know OR is 3 cm, radius of the smaller circle. OP and OQ are the radii of the bigger circle, which is 5 cm. Now if you take this triangle ORQ, which is a right triangle because the radius is perpendicular to the tangent at the point of contact. By Pythagoras theorem, we can find what is our RQ because we know what is OR and OQ. Similarly, if you take this triangle, we can find. Anyhow, you don't want to do another calculation because it is of same measurement. So what is RQ? The same you are going to get for PR. So once you know what is RQ, you can multiply it by 2. That will give you the length of PQ. Right? Hope you understood. So 6th and 7th question is homework to you. Let us move on to 8th question now. What is given in 8th question? 8th question, a quadrilateral ABCD is drawn to circumscribe a circle. Circumscribe a circle. Diagram is given in the textbook. Prove that AB plus CD is equals to AD plus BC. That's what we need to prove. Sum of the opposite sides are equal. It is given ABCD is a quadrilateral drawn to circumscribe a circle, right? So what you know about the tangents? Now we need to prove this is equal to this. But before that, what we know about the tangents drawn from an external point? They will be equal in length. Therefore, this length will be equal to this length. CR will be equal to CQ. Similarly, PB will be equal to BQ because these two are tangents drawn from the external point B. Similarly, AS is equal to AP because those are drawn from the external point A. DS will be equal to DP since they are drawn from the external point D. Right? So from this we can easily arrive at our conclusion. What are we going to do? Add all the left hand side and right hand side. One thing you have to notice here, while writing your equalities, write properly. When you are writing CR plus CR is equal to CQ, when you are writing for this, write BP is equal to BQ. I mean, you see to that CQ and BQ comes to same side of the equation. Anyhow, BQ equal to BP is also right statement. But when you are adding all the left hand side and right hand side, you will get a different answer. So to arrive at our required answer, make your not assumption, conclusions in the proper way as you need. Okay. Hope you got it, what I told you. I repeat, what I told you is, when you are writing your equalities, write in this way. If you are writing CR equal to CQ, when you are writing BP equal to BQ, see to it that CQ and BQ comes on one side. Then only while adding, you will get CQ plus BQ is equal to BC. Similarly, while you are writing this AP, BP, see to it, it comes on the same side of the equation so that while adding, you will get AB. Same way, AS and DS, DR and DC. Alright. Once you make all these equations, now what are we going to do? We are going to add all the left hand side and the right hand side. So CR plus DR, CR plus DR is nothing but CD. Right. Similarly, BP plus AP is nothing but AB. So if we club that, we will get our required answer. That's what we need to prove. So we didn't use anything here except only one result. The tangent drawn from the external point are equal in length. Using that, we have proved that the opposite sides of the quadrilateral are equal in length. Sum of the opposite sides are equal in length. Sum of the opposite sides are equal in a quadrilateral. Not in all quadrilateral. A quadrilateral which is circumscribed on a circle. Okay. Hope you understood. Let us move on to the next question. Ninth question is, they have given you this figure in the question and they have told you xy, x dash, y dash are two parallel tangents to a circle with center O. There is another tangent AB with point of contact C intersecting xy at A, x dash, y dash at B. Prove that angle AOB equal to 90 degree. We need to prove this angle is 90 degree. How can we prove this? We are going to use first congruency here. What are we going to tell here is this part of the triangle, this triangle is congruent to this triangle. Therefore, by CPCT, this angle will become equal to this. Similarly, we will prove this angle is equal to this. Okay, this angle is equal to this and this angle is equal to this. But what is sum of all the four angles is 180 degree because PQ is a diameter. It's a straight line. Alright. Now we proved this angle is this angle is equal to this. Therefore, if we make it as twice this angle plus this angle, we will arrive that the center angle is 90 degree. This is what the logic behind the problem. Let us see the proof. So as I told you, first let us prove this triangle is congruent to this triangle. So consider OPA and OCA. Right? What do you see here? OP is equal to OC because both are radii and OA is a common side. And what about AP? See, this side is equal to this side because both are radius and we know this is a common side. And what about AP and AC? AP and AC are two tangents drawn from an external point A. Therefore, they will be equal in length. So, all the three sides of the triangle are equal. Therefore, by SSS congruency criteria, these two triangles will become congruent. Therefore, by CPCT, POA, this angle will be equal to AOC, this angle. Right? This is equal to this. Similarly, we can prove these two triangles are congruent and hence angle COB, this angle will become equal to angle this. Right? Now, as I told you, sum of all the four angles is equal to what? 180 degree since it lies on a straight line. Yes, but we know POA is equal to AOC. So, we can replace POA as AOC itself. So, I have written 2 times AOC. Similarly, just now we told COB is same as BOQ. So, instead of BOQ, I can write COB itself. So, twice the COB, which is equal to 180 degree. Right? So, if I take 2 as common and if I bring it to the other side, it will come to the denominator. So, it has become 90 degree. So, what is AOC plus COB? AOC plus COB. This angle plus this angle is nothing but AOB. So, we proved angle AOB equal to 90 degree. That's what we need to prove here. Right? So, what we did, we proved the congruency of those two triangles in order to tell that OA bisects that angle. Similarly, that OB bisects. So, once we proved, we have used the angle on a straight line property. Alright? Hope you understood. Let us move on to 10th question. 10th question is, prove that the angle between they didn't give you the diagram. You have to draw the diagram. Prove that the angle between the tangents drawn from an external point. Angle between the tangents drawn from an external point. P is the external point and these are two tangents and this is the angle between the two tangents to a circle is supplementary to the angle subtended by the line segment joining the point of contacts at the center. So what do they say? We need to prove that this angle is supplementary to this angle. Supplementary means what? Sum of those two angles is 180 degree. So we need to prove angle APB is equals plus angle AOB equal to 180 degree. That's what we need to prove. For this, first you should understand the question and draw the diagram properly. Right? So it is given, prove that the angle between the two tangents drawn from an external point to a circle is supplementary to the angle subtended by the line segment joining the point of contact. Line segment joining the point of contact at the center. Right? This can be easily proved because on seeing this, what you know, OB and since O is the center, OA and OB are the radius and they are drawn at the point of contact. Therefore, these two angles are 90 degree. And when you see OAPB is a what? Quadrilateral. What is angle sum property of a quadrilateral? Sum of all the 4 angles is 360 degree. Out of 4 angles, we got 2 angles is 90 degree. So 90 plus 90 is 180. So 360 minus 180 is going to be 180. Therefore, sum of other 2 angles is going to be 180. Yes, I repeat, AB, PB is a quadrilateral. We know these 2 angles are 90 degree because radius perpendicular to the tangent at the point of contact, that we know. Now simply we are going to apply the angle sum property of a quadrilateral. So sum of all the 4 angles is equal to 360 degree. In this we know this is 90 degree, this is also 90 degree. Therefore angle APB plus angle BOA equal to 360 degree. What is 90 plus 90? 180. I am going to bring this 180 to the other side. So it has become 360 minus 180, which is 180. Hence we proved sum of this angle plus this angle is 180 degree, which means they are supplementary. Right? Hope you understood. It's quite easy. Let us move on to our 11th question. Our 11th question is, prove that the parallelogram circumscribing a circle is a rhombus. Prove that the parallelogram circumscribing a circle is a rhombus. See, just like this. This is a circle and this is a quadrilateral. Now, it is given the quadrilateral circumscribing a circle is a parallelogram. Now, they have clearly given ABCD is a parallelogram. What do you know about a parallelogram? Opposite sides are equal and parallel, right? Keep it in your mind. Now we need to prove that is a rhombus. Is a rhombus. A parallelogram circumscribing a circle is a rhombus. We need to prove that it is a rhombus. So how can we prove this? You have to prove in the same way as we did our 8th question. In 8th question, what we told, AB plus CD is equal to AD plus BC. Right? AB plus CD is equal to AD plus BC. Now, since in the 11th question it is a parallelogram, AB is equal to CD, right? So, instead of CD, I can write AB here. So, AB plus AB I will get. Here, AD plus BC. So, instead of AD, I can write BC. So, I will get 2 times BC. So, 2 times AB is equal to 2 times BC, which means AB is equal to BC. So, we proved adjacent sides are also equal. In a parallelogram, opposite sides are equal. Now, we proved the adjacent sides also equal. Therefore, it will become a rhombus only, no? Because this side is equal to this side already. Now we proved this is equal to this. So this will become equal to this will become equal to this, and hence all the 4 sides have become equal, and hence it is a rhombus. Right? So how will you write the proof of the 11th question? You have to write the proof of the 8th question first. You have to prove till this AB plus CD is equal to. How we proved this? We proved a single theorem that the tangents drawn from an external point are equal in length. We have drawn all the equations and we have added all the left hand side and right hand side. We arrived at this result. After this, you have to write, since it is a parallelogram, we know AB equal to CD and AD equal to BC. So replace CD by AB and AD by BC. We will get 2AB is equal to 2BC, which implies AB equal to BC. And hence adjacent sides are equal. Since adjacent sides are equal in a parallelogram, it is a rhombus. Right? So I am not going to solve this problem. I have given you the entire proof. You are going to do it. Let us move on to the 12th question now. A triangle ABC is drawn. See, this is a triangle ABC is drawn to circumscribe a circle of radius 4 cm such that the segments BD and DC, into which BC is divided by the point of contact D or of length 8 cm and 6 cm. Find the sides AB and AC. We need to find what is AB and AC, right? The proof may look quite lengthy, but the logic behind is very simple. Okay, so they asked you to find the length of AB and AC, and it is given BD is 8 centimeter, CD is 6 centimeter, and OD is 4 centimeter. This is what given in the question. And we know these two are tangents drawn from an external point B. Therefore, if BD is 8 centimeter, BE is also 8 centimeter. And CD 6 centimeter means CF is also 6 centimeter. We don't know this length AF and AE. Once we know this, either AE or AF, we can very well find what is our AB and AC. So our aim is to find this length AE or AF, and we know very well AE is equal to AF because both are tangents drawn from an external point. Yes. Now the logic behind this problem is, what are we going to do is, we are going to find the area of this entire triangle ABC using Heron's formula. What is Heron's formula? Square root of S into S minus A into S minus B into S minus C. Okay. Because we know all the three sides of a triangle. After that, we are going to find the area of this triangle BOC, area of this triangle. Similarly, area of AOB and area of triangle AOC. If we add all these three areas, won't we get the entire area of the triangle? So that's what we are going to do. We are going to equate the area of triangle ABC to area of triangle BOC, area of triangle AOB, area of triangle AOC. That's what we are going to do. Okay. So first let us find the area of the triangle ABC. Let us find the area of the triangle ABC using Heron's formula. So S is semi-perimeter. So we have to add all the sides and divide by 2. Okay. So what is our first side? BC, or take AB. AB is going to be 8 plus X. And AC is going to be 6 plus X, and BC is going to be 6 plus 8 divided by 2. So we got 14 plus X as our S. S is semi-perimeter, right? 14 plus X. Now let us substitute the area of the triangle formula slowly and carefully to avoid your mistakes. S is 14 plus X into S minus A. 14 plus X minus, your first side is AB is 8 plus X. So 14 plus X minus 8 plus X into 14 plus X S minus your B is 14, and 14 plus X minus your C is 6 plus X. You can take ABC in any order, it doesn't matter. Right? So 14 plus X minus X will get cancelled. So 14 minus 8 is 6. Plus 14 minus 14, here it will get cancelled. So we got X. Here plus X minus X will get cancelled. 14 minus 6 is 8. So again X into 14 plus X, 6 can be written as 2 3s are 8 is 2 into 2 into 2. So inside is square root. So we have taken 4 out. So we left out with 4 into square root of 3x into 14 plus X. Now this is what the area of the triangle ABC. Let us keep it aside. Now as I told you, now we are going to find the area of the triangle OBC, not using Heron's formula because we don't know all the three sides, but we know the height. How do you say this is height? Because we know this is perpendicular. A radius drawn from the center at the point of contact is perpendicular. Perpendicular distance is nothing but height, and moreover OD, OE, OF are all radius, therefore all are going to be 4 centimeter only. Right? Now in this triangle OBC, we know the base and the height. So we are going to use the formula half into base into height. So half into base is 6 plus 8, 14 into height is 4, which is 28. Similarly for the other two triangles, base is going to be 8 plus x, height is going to be 4, and here base is going to be 6 plus x and height is going to be 4. So substitute in the formula, we got this. So as I told you, area of triangle ABC can be arrived at adding all these three areas. So this is equal to 28 plus 2 into 8 plus x plus 2 into 6 plus x. Right? Now simplify it. We got 4x plus 56. Here also we got 4 into square root of. So I am going to divide throughout by 4. Divide throughout by 4. And then we have square root. So squaring on both sides. We get 14 plus x, here x plus 14 the whole square. So one term we can cancel. So 3x equal to x plus 14. So if I bring this x to the other side, it will become 3x minus x, which is 2x. 2x is 14, so x is 7. So we got what is our x. Once we got our x, we can very well find the AB and AC length by substituting, because AB is x plus 8 and AC is x plus 6. Right? Hope you understood what we did here. Yes. Let us move on to the last question, 13th one. They asked you to prove that opposite sides of a quadrilateral circumscribing a circle subtend supplementary angles at the center. The opposite sides subtend supplementary angles at the center, which means this angle plus this angle we have to prove equal to 180 degree. Opposite angles subtend supplementary angles at the center. That's what we need to prove. AOB plus COD equal to 180 degree. Similarly, COB plus DOA equal to 180 degree. Okay. Here also we are going to use the concept which we have proved already. But here again I have done it for you, for your understanding. So what we are going to do here is, we are going to tell angle 1 equal to angle 8. What is this angle 1 and angle 8 are made by the external point with the center. Right? So we are going to consider triangle DOR, this triangle and this triangle. SOD. Okay. We are going to consider these two triangles. So what do you know? Hope you got it in your mind. We have done it for question number I think 9th question. We have done this. For this problem we have done this. We told this part of the triangle is congruent to this part of the triangle. These two triangles are congruent. Therefore this angle will be equal to this angle. We have proved this already. The same thing we are going to do it here. D is here. So we are going to take these two triangles, and we know this is common side. These two are tangents from an external point and these two are radius. Therefore by SSS congruency rule, these two triangles will become congruent. Therefore by CPCT, angle 1 equal to angle 8. Similarly everywhere 2 equal to 3, then 4 equal to 5, then 6 equals to 7. Keep it aside. Now add all the angles. What do you know? Sum of all the angles is equal to 360 degree, because it is angle around a point. Right? Now here what are we going to do? We already told that angle 1 is equal to angle 8. Angle 1 is equal to angle 8. So I can replace it as twice angle 1. Then angle 2 equals to angle 3. So I can write twice angle 2. Angle 4 equals to angle 5. So I can write twice angle 5. Angle 6 is equal to angle 7. So I can write twice angle 6. Right? Why I have written 1, 2, 5, 6? Why I didn't write 1, 2, 4, 7? Why? Because we need to prove the opposite angles only we need to prove. So we need 1, 2, 5, 6 only. So that's why we have written in that way. Yes, so according to your need, you have to rewrite that. So 2 into angle 1 plus angle 2 plus angle 5 plus angle 6 equal to 360 degree. So bring this 2 to the other side. So it is going to be 180. 1 plus 2 is nothing but DOC. 5 plus 6 is nothing but AOB. Thus we proved the opposite angles. The angles subtended at the center by the opposite sides of a quadrilateral are supplementary. Right? Hope you understood. And if you have any doubts, you can ask me. With this, let us wind up today's class and do exercise 10.2 question number 6, 7 and 11 as homework, and kindly redo all these problems which I have done. Don't simply listen to the video like a cinema or a movie. You redo it after listening to the video. You redo it without seeing the solution. Then only you will come to know how to proceed every problem. Right? So do these 3 problems as homework, and if you have doubts, you can ask me. Thank you, students.